welcome to this bonus episode of the Curious Cube where we're celebrating Pi Day, which is today, March 14th.
Woo! Pi Day. 3.14. I don't care about the
Yeah,
rest.
how many digits have you memorized, by the way? Out of curiosity.
Why do people care about this so much?
Because it's
Like-
cool, and I like comparing myself to other people.
Yeah. Yeah, so for our, our viewers who are not in a country where you write the day before the month might be wondering why today is Pi Day. So it's because it's 314. And so, in some other countries, maybe they have Pi Day on July 22nd because they like to write pi because they would write it as 22/7.
Alternatively, you could have it on April 31st.
I had a friend who thought that pi was literally equal to 22/7. He was like, I know it's irrational, but isn't it equal to that? I was like, no.
Yeah, there are, I guess people have a lot of misconceptions about pi, but if everyone were an expert on calculus, they would clearly know that pi is not equal to 22/7 because, in fact, calculus lets you take a region that has area exactly 22/7 minus pi. But calculus, I don't want to go into too much detail about that, but we'll talk about how calculus and pi relate on the next actual episode of the Curious Cube. But
which will be in 2 days.
Yes, on Wednesday.
Can't you just make the region a rectangle with width 1 and height 22/7 minus pi?
Very astute, Holden.
You could, but that's not very convincing. But yeah.
We really just jumped over the how many digits of pi can you memorize? Like 20 something. I think I tried more when I was in elementary school, but it's just random numbers.
I mean, for me, maybe it's around 30, but this is like one of those things where computers have long since surpassed humans.
Yeah, the record for people is like 69,000, like a little under 70,000 somewhere. And then a computer, I think at the moment it's like 5 trillion.
Yeah, I memorized all the digits of pi since there's only 10 of them.
Wow, Holden's so smart.
I agree.
The first time I celebrated Pi Day, I don't remember exactly what year this was, but I went to HEB, or I went to the grocery store at the end of the day, and there were no pies. I'm not sure why. There are no. Actually, no, I know exactly why, but there were no pies, so I ended up getting a cake, and then I had like the people write like a pie on it.
Hilarious. Yeah. What math-related things can we?
It was circular. Okay.
Talk about.
Oh, good. Okay. Well, I mean, there is Archimedes. He had some interesting,
Wait, like what?
Like he did some of the first results about pi, if I'm remembering correctly. Like the thing about like he circumscribed bigger and smaller polygons like to better and better get a circle. And so I think he found like pi is between like 3 and 10/71 and 3 and 1/7.
I think he used regular polygons and specifically computed the perimeter of regular polygons and then noted that if the regular polygon surrounds a circle, then the perimeter of the regular polygon has to be more than the perimeter of the circle, which is just, circumference, same thing, which is just like 2 pi if your radius is 1.
There's also like that one, fundamental theorem or like, it's not very fundamental at all, but e to the power of pi I plus 1 is equal to 0. Wow, what a beautiful theorem.
Yeah, what does that even supposed to mean? And why is it special?
Well, I mean, so like, I guess a lot of people... So, okay, first of all, for people who are not familiar with it, E is this special number that's about like 2.718. I guess those of you who are very mathematically inclined might have celebrated it back in February. And then I is sort of what complex numbers are built around. It's sort of this number that's not on the real number line. It's sort of perpendicular like on a line perpendicular to it, so that I squared is -1. But then, like, you come up with this issue, which is like, well, if you have this number that's like, it's not even on the real number line, how are you putting it in an exponent? And so, like, it does have meaning in the sense that if you're going to sort of, it's a bit hard. Like,
I know there's a nice 3 blue 1 brown video on it, right?
I can believe that. That seems like the sort of
probably
thing.
is.
Yeah.
That seems like his sort of thing.
It explains what it actually means to like raise a real number to a complex exponent.
But yeah, basically, I think I've heard it explained as like, there is some most natural way of extending this function e to the x from the real numbers to the complex numbers. And when you do this, then you get e to the pi I equals -1. But, maybe, it's pretty neat. But
see, what I always heard it as, it's this formula connecting the 5 fundamental constants: E, pi, I, 0, and 1.
Wait, can't you just like I can come up with a formula that uses all 5 as well. Like, can't you just do E times I times pi all to the power of 0 equals 1?
You know what? That's pretty fundamental too. That's a true statement, and it's also very, it's fundamental.
Amazing. But yeah. Oh, when I said earlier about Archimedes like doing work on pi, definitely like ancient Greece was not the only place in the ancient world where mathematicians were doing pi. There was mathematicians in India and China and Babylon were also finding out neat stuff about pi. It's
and independently too. It's pretty interesting.
Yeah, it's not just about Greece. There was lots of interesting math, people doing that like all over the ancient world.
Luke, do you know much about ancient math history?
I mean, I know how to look at Wikipedia.
That's fair.
So yeah, I'm not exactly an expert. I know a thing or two, but I know how to look at Wikipedia. And
do you know how to look at Wikipedia without wasting time? Because this is a skill I need to learn.
Good question. I waste my time on other things instead. Anyway, that should do it for our Pi Day episode. So stay tuned for our actual episode in 2 days. We will see you then.
Bye.
Bye.